Hello, today we are going to talk about the KDE's Season of KDE 2023 idea accessibility work on improving the accessibility of Calendar, neochat and other QML applications. So let's get from the start. So we write in Google KDE Wikis Season of KDE. It suggests this wiki page, community.kde.org/season of KDE. So mentored projects for KDE, a time limit, a certification of completion, a t-shirt. Okay, and the ideas for the current year, 2023. We are waiting for more ideas to be added to this wiki page, but currently there's 2 ideas about accessibility, 2 about sustainability, and 1 about systematization. Okay. There's a sample that you can use to add your own idea to this wiki page, but you should not add an idea without actually being able to mentor it. Okay. So the first idea in this list is that a screen reader such as Orca should be able to read as much as possible from GUI applications that are written in QML by the KDE community. So such applications might be written, all of the GUI might be written in QML or just parts of it, such as the start page in Qt, the text editor. Such applications are Calendar, the new calendar, neochat, the matrix client, there's tokodon, the mastodon client, there's the new alternative to kcalc, which is called kalk, like this, without any C's. Then there's Plasma Discover, the App Store, etc. So some of these applications use QML, which is a programming language, use Qt Quick Controls 2, use Kirigami. Okay, and we'll look at one such an application, which is called tokodon. And then, so this thing will be mentored by Karl Spahn, and he recommends that you use this matrix channel, kd-accessibility:kd.org. And again, you should improve the way screen readers read GUI elements such as buttons, tree views, list views, combo boxes, etc. And make sure the keyboard navigation works correctly. So when you press the tab key, it jumps to the correct button. All of the buttons that can be accessed with a mouse can be accessible with just using the keyboard, no mouses. Okay, so this would be the first part of the idea, and then Karl Spahn added a second part to the idea when we're using the accessibility API, which allows us to read what's on a GUI application and allows us to act on the GUI application. So we can click buttons, for instance, if we know the text that's displayed on that button. We can automate the application. So for instance, we can start the application, find a close button in there, push it using the accessibility framework, and then make sure that the application actually closes. Or we can close the left sidebar and then open it up again. So all sorts of UI actions we can now perform using GUI automation, using the accessibility framework, which is in contrast to another way of doing GUI tests, which is clicking on absolute coordinates with the mouse. So you could say click on whatever is at 100 pixels by 300 pixels x by y coordinates. But that's those tests break very easily when you change the minimal things in the UI, such as a theme. But using accessibility, if the text in that button is never changed, then you can always find all of the buttons in the application, in the graphical user interface, find the button that has the text that you're expecting, and that using the accessibility framework, you can say click on that button. So it's less flaky GUI testing. Okay, so let's go for the first part. So the first part we will exemplify with the application tokodon. For that, you should be able to build tokodon using kdesrc-build. So let's open a console. So we go kdesrc-build and then the name of the application tokodon. Okay. So it says that it's going to build 35 KDE Git repositories in the correct order. So most of them are from the KDE frameworks version 5, ecstasy, make modules, kcorridons, kconfig, kinternationalization, karchive, kwidgets, add-ons, etc. And then there's one for Kirigami add-ons, and then Kirigami is part of the KDE frameworks. So there's Kirigami add-ons, which actually has, for instance, the about box for Kirigami applications. And then the very last one, the 35th of 35 KDE Git repositories, is tokodon, which is the application. So it builds a ton of libraries, and at the end it builds the application, which is actually an executable, just one file called tokodon. Okay, and that file gets installed in tilde/kd/usr/bin/tokodon. Okay, how do you make kdesrc-build work? Well, you follow the wiki page. So when you start in working for KDE season of code and you don't know how to contribute to KDE, there's another metrics channel that's called KDE Welcome, which you should join. And in the description of the channel, in the status of the channel, there's a URL which points to the getting involved page, which is actually this page. Okay, so because you're going to work on accessibility, you will need to read 2 pages from here. So you'll need to read the accessibility page, pretty short. Make sure you're part of KDE accessibility metrics channel. And then you need to read the page for get involved development. Most of this page is about how you set up kdesrc-build. So the steps are: use any of these Linux distributions either on your hardware machine or in a virtual machine. Don't use these distributions. If you have such a thing installed on your hardware machine, then you should have a virtual machine with one of the better suited Linux distributions for kdesrc-build. Then you follow the steps to set up kdesrc-build. So you should watch this video and understand what's happening here. There's more videos tailored for your Linux distribution. So if you're on Arch or Arch-derived distributions, then this is your guide. There's one for KDE Neon, Kubuntu, OpenSUSE, Tumbleweed, Fedora, KDE Spin. Okay. And then there's my YouTube channel. For instance, this is the newest how to set up kdesrc-build tutorial screen recording for KDE Neon Developer Edition. It creates a VirtualBox VM, but you could create a QEMU VM. And then follow these steps if you're going to be developing using the Linux distribution KDE Neon Developer Edition. Okay. So the steps are, the first step, let's say you're on Endeavour OS, which is based on Arch. Run this command line, install git GUI, git k, and configure your git username and git email. So you should have an email address that's dedicated for you contributing to the KDE community and to other open source projects. So I suggest you use gmail.com. I suggest that the email address contains your preferred first name, so Marius in my case, and then parts of the other names like nmariusp1@gmail.com in my case. In here put at least your favorite first name, like Marius in my case. Okay. Then so this was step 1. Now step 2, run this command line chunk and this command line chunk. In here, when you say echo $path, make sure that where are you? kdesrc-build directory, the directory where you git cloned kdesrc-build, is in the path, at the start of the path. So tilde/kd/src/kdesrc-build should be at the start of the path. Otherwise, it will not be able to find kdesrc-build executable, which is actually a Perl script. Okay, so either you should either log out and log in to make the changes to the path environment variable available, or you just reboot the machine. The alternative is to source the bashrc file. Okay. So the initial setup will install as many packages from your Linux distribution as possible. So Qt, all of its modules, dependencies of Qt, and then dependencies of the KDE frameworks version 5. So the next step, we will ignore Qt because we're on a Linux distribution that has the correct version of Qt available, which should be at least 5.15. Then we're going to disable indexing for our development environment, either uncheck enable file search or add tilde/kde to the not indexed specific configuration folder. Okay. Then we need to install at least the dependencies needed to build KDE frameworks version 5, all of them. So the steps are nothing in here for Endeavour OS Arch. Okay. For all of the KDE frameworks version 5, for Arch, you need to run this long command line. And then for bonus points, you also install all of the dependencies for KDE Plasma using this command line. Okay. The next step, since we have all of the distributions packages installed such that we can build all of the KDE framework version 5, we're just going to do that, kdesrc-build frameworks. And then we're going to build the actual application, which is called tokodon in our case, so kdesrc-build, and then the name of the application, which we did, and it was successful. Okay. Then there's two ways of running the freshly compiled application, either kdesrc-run and then the name of the application, tokodon in our case, or source tilde/kd/build/ the name of the application, tokodon/prefix.sh, and then you can just start tokodon without any path. So let's do this alternative. Ctrl-Shift-V and tokodon. Okay, there's auto-completion. The application starts. I don't have the application installed, tokodon installed from, so this machine runs Ubuntu 22.10. I do not have tokodon installed from Ubuntu packages, just from kdesrc-build. Now we're going to start orca and see if we can read the graphical user interface. Ctrl-Shift-T. Orca is the screen reader, so in my case I install it using apt install orca. like this. It says it's already installed. I started. It's a GUI-less application.
Screen reader on. Build a layered pane. Login page tab. Blank.
So it says login page, which is correct, but then it doesn't say instance. You're in the text box where you can enter your instance URL for tokodon.
Blank.
In here it says blank instead of saying you're in the text box where you can enter the mastodon username. Okay.
Ignore SSL errors.
So in here it doesn't say that ignore SSL errors is a configurable value and it's turned off.
Caps lock tab. Continue.
Continue doesn't say that it's an expandable.
Return.
Return doesn't expand expandable.
Return. Space.
Space instead really does what it should do, which is this continue thing is probably a button, so it pressed the button. In here it doesn't say open settings.
Layered pane. Tab. Show link preview.
So it doesn't say it's disabled.
Tab. Add account.
Okay, this works correctly.
Tab. Enable automatic spell tab. Ignore upper tab. Ignore high tab. Detect language automatically checkbox checked.
Checkbox checked. Okay, so it says that it's a checkbox and it's checked. So the same thing should say about these things. It's a checkbox and it's not checked. It's a different control that looks differently, but it still behaves like a checkbox. It only has on or off possibilities. It's not even a tri-state checkbox. Okay. So let's go to the combo box.
Selected default language :
Okay. How do I act on this combo box?
Space. Tab. Additional spell checking languages. Tab. Oh.
How do I? So all of the graphical user interface should be accessible without the mouse, and I don't know how to enter this combo box. I'm in the wrong place. If I go up and down with the keyboard, it acts on the settings page, not on the values inside of the combo box. Okay, so this is what you're going to be required. If you have a button or a radio button that it's not read by the orca screen reader, then you should add such description, such text. And you do that by editing just QML files. That's what's required in part 1. Build using kdesrc-build one of the applications that use QML from KDE, such as tokodon. Read using orca all of the UI, and when you find a button or a checkbox or something that's not that orca cannot read, you add that text by editing the QML file.
Tab. EPLB3. Space. About tokodon page tab. Tab. Tokodon 22.11.2 Mastodon client.
So again, it reads the wrong page. It doesn't read this pop-up thing. It reads the thing that's modal and hidden behind the modal dialog.
Tab. GPL escape.
Okay, you will not be able to fix such fundamental issues like not knowing if it's a combo box or not, or the wrong focus on the wrong GUI control dialog, etc. You're just required to fix which elements are defined in QML but don't have an accessible description or a label available. You should add such a thing.
Layered pane. About tokodon page tab. Carl Schwan maintainer. Left report a bug. Tab. Carl Schwan maintainer. Left report a bug.
So report a bug jumps to authors instead of jumping to libraries in use.
Tab. Carl Schwan maintainer. Left report a bug.
Okay, so this is probably either the this label is not focusable, so Orca doesn't know that KDE Framework 5 is focused, so it cannot really read it. It only reads focus things, so that's a problem. And or maybe the tab order is wrong. So if the tab order jumps from reporter bug to authors, you will need to look inside of the QML file and decide. Okay, so this is the first application that we use for accessibility, the screen reader orca, and then we have another one which is called exerciser. This application. So we should make sure that tokodon is available in the list, and it's available. There's a configure which is of type frame. There's a GPL v3 label. Let's look at the GPL v3. So it's not in fact a label, it's a button, right? Because when you click on it, it shows this modal dialog. So maybe it should not be of type label, should be of type push button or something. And then there's a validator which tries to find as many accessibility issues on this page as possible, on this GPL v3 actually. Okay, says actionable label is not focusable or selectable. Which means what? It's focusable and selectable. So many accessibility errors. I don't know how to interpret these errors. There's the source code to exerciser, which is Python. You can look inside and see how I look inside the source code for the exerciser application. I open I have installed the active state IDE, which is named what? Which is named Komodo. Okay, so the exerciser application is in fact a Python application that starts the executable USR bin exerciser. Okay, and all of the application lives in here. USR lib Python 3, these packages and exerciser. Okay, so these are the files. The entry point is /usr/bin/exerciser, which is actually a Python file that doesn't have any extension. And then that thing calls, loads this file. Where is it? Exerciser.py from this path. So for that, in Komodo IDE, I go in this left hand side tree view that says places. I go open directory. I select the directory /usr/lib Python 3 this package is exerciser. I go open, and then I say exerciser.py. I open this file. I go run, and it says what should I run, and I select not to run this file. Where is the copy path? So I don't want to run this file because this file is actually called by /usr/bin/exerciser. You cannot start this application from here. there's code that needs to be run first. So that's why I select the thing to run is /usr/bin/exerciser. And that's it. You put breakpoints in the constructor of the main class, and then you can use the debugger. So F5 to go to the next breakpoint, step over F10, step in F11, step out, Shift F8. Okay, so F10, F10, F5. Okay, and now the application exerciser starts. You need to remember that you're not running as the local user, Linux user root. You're running as your non-root account, but this account has sudo powers to become a super user. We're not going to use that. And we're actually running the debugger over files that are owned by root and not writable by my current user. So I'm not able to edit these files and save them because I'm not the root user. Okay, so if you don't plan to actually edit this application, you can run it in the debugger and see exactly how this icon comes from. You know, how the interface viewer tree is populated, what the validate button does. You can see all of these things are plain text, the source code is available in here. Okay. So for instance, this icon is Ctrl-Shift-F icon, and it should ignore case, find all. There's an accessible tree view, so I'm guessing this is the thing, the tree view, and it says get icon, and this is a function. I'm searching for it. This is the source code of the function. I'm going to put a breakpoint in here. I'm going to go view refresh registry. No, not. Okay. Let's stop the debugger and start the debugger again. So the same thing, /usr/bin/exerciser. Go. Okay. We're in the first breakpoint that we have at the actual start of the application. I went F5 to go to the next breakpoint, which is in the function get icon. Okay, and now we're in the function get icon, and it says get a GTK icon theme. There's a thing which is called unaccessible, which is the parameter to this method, which you can inspect in here. It's a GObject binding. There's a method called getRole, a method called getRoleName. If role is application, then it tries to call the property name. Okay. We can't really inspect these things because they're just GTK methods, so you will need to create local variables where you assign this the return of this function to, and then you can inspect the local variables. Okay, if it cannot find a suitable icon, then it uses the WNCK library to get the icon that's displayed in the icons only taskbar. So from the X11 window manager. Okay, so enough about how to debug exerciser. So we've built tokodon, we've read it using orca, we've inspected it using exerciser. The next thing to do is to actually look at the tokodon source code, see where the QML files are, how do we edit them. So for that, I'm going to close tokodon and show you how kdesrc-build works. So kdesrc-build has a ~kd directory and a configuration file. Okay, the configuration file was created at this step, kdesrc-build initial setup. These are the photo values. This I have replaced from rel with debinfo to debug, really important to me, because I want to run the build application, the application's build using kdesrc-build using a debugger such as GDB, or the front end to GDB in the various IDEs such as Qt Creator, the IDE that I use. Number, of course, should be the maximum such that it builds as fast as possible. And these are the defaults. So the default kdesrc-build modules and module sets. Okay. And the directories are src. In here, there's a subdirectory where each of the KDE Git repositories gets git cloned. Then there's an intermediate directory for each KDE Git repository, which is ~kd/build tokodon in this case, for tokodon. Okay, so there's the ~kd/build/tokodon directory, which is actually build artifacts, the results of building the C++ project tokodon, CMake intermediate files, and then as the last step, kdesrc-build runs make space install, and it installs into this prefix, so ~kd/usr, and for tokodon bin, and then tokodon. This huge executable that actually contains all of the QML files inside as resources. Okay. Then, as shown in, for instance, this YouTube video of mine, so how to install Qt Creator from the Qt framework website, you should actually do this. You should install Qt Creator, the latest version from the Qt framework website. And then we're going to open in the Qt Creator ID the KDE project tokodon. So that's done. We open Qt Creator, file, open file or project. We want to open the directory where tokodon was git cloned. So this is the one. And in here we open the cmake list.txt file. Okay. So this is Qt Creator, is an integrated development environment. It knows Qt, it knows QML, it knows how to edit Qt widgets.ui files. It knows about QRC resources. It knows about CMake, front end for the GDB debugger. So everything that's needed by me for now for the tokodon project is available via this integrated development environment, Qt Creator. Okay, so the first thing is to put the source code in Qt Creator. The second thing is to put the build directory in here. So we go projects, manage kits. We remove all of the kits under manual that except this italic one, which is desktop default. So we keep desktop default, but we remove the rest. We need to remove imported kit. Apply, okay. Go to manage kits again. Okay, so just one kit under manual, desktop default, which is italic. And then we go import existing build. We paste the path where we git cloned the KDE Git repo, where kdesrc-build has git cloned the Git repository tokodon. We replace src with build. Press enter. And now we have the following things. We have a build configuration which is called debug2, which we're going to use, which uses the correct GCC, the correct Qt, the correct install directory, so the prefix directory, it takes the KDE frameworks from libraries and include files from ~kd/usr, not from /usr. So we want to build all of the KDE Git repositories using kdesrc and then use all of the KDE Git repositories from ~kd/usr, not from /usr. So none of the KDE Git repositories, none of the KDE shared libraries, include files, CMake files, or binaries executable, we should take from our Linux distribution, which is Ubuntu 22.10 in my case. So all of these things, the KDE things, should be taken from ~KDE. Okay, this is what actually importing the build directory has achieved. Okay, so again, remain on the debug to build configuration. It's debug2 because I have edited ~.config/kdesrc-buildrc such that the CMake build configuration is not real with debinfo but debug. That's why it's named debug2. Okay, it has run CMake configure already, but we can run it again. Build run CMake. So we see that it's successful. Doesn't complain about anything. Then we can build using the build project tokodon Ctrl+B hammer button in the top left, in the bottom left corner of the application Qt Creator. We are looking at the output in this tab, which is called compile output Alt+4. It says 100%, so it's successful. And now we can debug this thing. So let's see what we're going to debug. These are the entry points, the executables which are created when you compile the tokodon KDE Git repository. So there's 3 tests: post test, search test, timeline test, and the executable itself, the GUI executable tokodon, the 11 megabyte executable. So let's debug tokodon. Let's find, so these things are actually CMake targets of type executable. Let's find the source code for the tokodon executable. So we go to the edit, switch to edit mode, Ctrl+2. In here, in the left-hand sidebar, we have 2 useful views. One is called file system, similar to if you would open in Visual Studio Code this directory, so ~kd/src/tokodon shows you the directories and files. This is the file system view, and we can use the projects view, which is actually a CMake view, so it shows the CMake targets from this project, from the top level CMake list.txt file. Okay, so it says that there's a thing which is called autotests, which has 3 executables: post targets, CMake targets, post test, search test, timeline test, and we know that. And then there's 2 more targets, which one is called tokodon, which contains QRC, which is Qt resources. These files will be embedded inside of the executable binary file tokodon. And the content in there is icons, so elephant SVG, probably the icon for Mastodon, and then extra icons in SVG format such that they are resizable to any resolution. And then there's the user interface, which is written in .qml files, so it uses the QML programming language. It's declarative, so it's a tree of things. It resembles JSON. It can contain JavaScript source code. I don't know where. Okay, so pairs of ID and then value. Internationalization I18N means that we're going to take this string and if we should show tokodon in the French language, find the French translation, find the French translation for this string add account, and actually display the French version in the graphical user interface, not the English version of this string, if there's such a translation to French of this string. So this is actually a function which translates this thing into the correct language to be displayed in the graphical user interface. Okay, this is how the QRC protocol. It says that it's going to go into slash, which is this thing, and then it's going to go into content, so this thing, and then into UI, so this thing, and then into login page.qml, this thing. Okay, so when the form button delegate named add account with a text add account is clicked, so on click, this is an event implementation, then into the page stack, which is a element that exists in here, we should call this function with these parameters. So the name of a resource QML file, then I don't know what this is, an empty object, and then the object which has two properties, width and height. Okay, so in order to make more of the graphical user interface be readable using Orca, you will need to edit such files with the extension QML. Okay, you will ask, the KDE community has already done hundreds of Git commits like this to make sure that a button that's not readable by Orca in QML now is readable, has text for Orca. You can ask, and we will give you some merge requests that actually add such accessibility text to graphical user interface controls or QML. Okay, so all of these QML files, all of these SVG files get compiled into a resource, and that resource gets shoved into the executable tokodon. Okay, so there's just one source files in the CPP sense, so with just one C++ source code file, which is main.cpp. So we would expect that the entry point to this executable is either main.cpp or tokodon.cpp, and it's main.cpp. It only has one function, which is the free function main, which is actually the entry point to a C++ executable. We have put breakpoints in here. So at the start of the main function, we will be able to inspect what's the count of arguments, the list of arguments, and then we will be able to debug the rest of the application. For that, we're going to press the Start Debugging of Startup Project button. And first of all, we need to make sure that tokodon is not running, because tokodon has multi-instance protection, so you cannot open tokodon twice. Okay, so the debugger, which in fact is GDB, so it says GDB for tokodon, has stopped. So at breakpoint line 52 on thread 1, so there's just one thread, just one function, which is main. And here says the list of threads. Okay, let's remove all of the breakpoints. Delete all breakpoints. Yes, put a breakpoint again. So it remembers the list of breakpoints that you have per file and per project. Even if you remove from Qt Creator this project, and when you reopen this project, so tokodon in Qt Creator ID, it will remember the breakpoints you created previously. Okay, let's resize things around. So RGC This is about the command line with which tokodon was started. We can see the command line. So the command line is /home/nmariusp, so my username /kdesrc-build/tokodon/bin/tokodon. So not inside ~/kd/src, but inside ~/kd/build, the name of the KDE Git repository, and then there's a subdirectory bin, and then the executable, which is tokodon. Okay, so the command line has just one element. Argument count is 1, and the arguments are just the full path to the executable, not any other command line arguments. Okay, so we can inspect values in here, or if we hover. Okay, like this. This is the char pointer, so a basic C string, null terminated, UTF-8, and then an array of those things. Okay. It needs to call enable high DPI scaling for the QGUI application. So this is a namespace or a class. This is a static method. Let's navigate to it. So it's a static method and part of the class QCore application. Okay. In here we can see the all of the symbols that are exported by this QCore application.h file. The full path we can see by hovering on top of the tab, which it says it's in /usr/include /qt5/qtcore/qcore application.h. So all of the Qt things we take from /usr, from distributions packages, so deb files in my case, but all of the KDE things we take from tilde/KDE directory. We can close the tab, we go F10. So we're inside main.cpp. It calls another static method, set use system configuration. F11, the debugger shortcut are F5 to start debugging and to go to the next breakpoint, F10 to go to the next line in this current file, F11 to step into a called function, step out to pop the stack, so to exit the current function into the caller function, Shift F11. Okay, so now it creates the most important object in this application, which is called which is of type QApplication and called up, and a local declared on allocated on the stack, on the C++ stack, local variable. So F11. We don't have symbols for the QApplication constructor, so even if I went F11, it could not enter that. So we don't have debug symbols for Qt. We don't have source code for Qt. We only have include files in /usr/include. Okay. Then it says, is there a environment variable which is called Qt quick control style? No. Not Android, not Windows, so it could be FreeBSD or Linux. In that case, since we're running on probably on a desktop, it's going to use a theme that's suitable for desktop. So one that has scroll bars and the buttons use the KDE theme. Okay, so this is for internationalization. I don't know what this thing does. Sometimes when I go F11 to step into this static method, instead it steps into the evaluation of the parameters to this method. So in this case, the method expects a const QString reference, and we have passed it a const char pointer, so a C style string. So in fact, in here a QString is created out of this const char pointer, and this is such a constructor. So it says if not Qt no custom ASCII is defined, or not Qt restrict custom ASCII is defined, then it's okay for QString to be able to construct from const child pointer. Okay, so again we have access to /usr/include files from Qt, but not to CPP files from Qt. F11, this is a pimple for QString, AD pointer. Okay. It doesn't have symbols, debug symbols, so even if I press F10 it doesn't seem to do much, but in fact it steps to another place. So let's go Shift F11, Shift F11, so now we're back into the main.cpp file, F10, so this is about data, this is about this thing, so the about KD dialog, about dolphin dialog. Okay, it says the name of the application, who has written it, its license key, its license, where to report bugs, okay, so this is a problem. It should have started bugs.kd.org, the wizard for the correct application, which is Dolphin in this case. Okay. What else? So it says who wrote the application, translators, organization, where to report bugs. All of the KDE applications have K about data, even if they're written in Qt Widgets or in QML. Okay. And now it adds the about data to the application. So we can go F11 to see what's happening in there. So because it's a KDE Git repository, which is called kcalc, which is actually a KDE framework version 5, we have access to the CPP files, to the files with the source code. So we can actually see the implementation of methods, not just the signature of the methods. So the signature of the methods is in two places, in tilde/kd/src kabout data, and also in tilde/kd/include kabout data.h. So the h file is actually placed into available in two places, and the CPP file is only in one place, which is tilde/kd/src/kcalc, then kabout data.cpp. Okay, you can switch between CPP and h file using right-click switch header source F4, and goes to the correct place in tilde/kd/src, not in tilde/kd/include. Or you can navigate with Control-click. Okay, can navigate a lot. In order to close tabs, you either Control-W a lot, or you can close in the left-hand sidebar, which is called the left sidebar Alt-0. There's a view which is called Open Documents, where you can close the files that you don't need any longer, such as all of the SVG files, the QML file. Okay, so although we started from the KDE Git repository tokodon, now we're in another KDE Git repository, which is for kcore add-ons. But using the debugger, we can jump from one KDE Git repository to the other, but just using the debugger. When we're outside of the debugger, we can only jump to tilde/kd/include, not to the place where all of the other KDE frameworks version 5 were git cloned, in tilde/kd/src. Okay, so the debugger is really useful in order to read the source code that's actually executed from the KDE Git repositories that are not part of the current KDE Git repository, which is tokodon. Okay. So this is a singleton accessor, I'm going to guess. Yes, return self. And now it has access to the application, which is in fact this thing. So this thing is accessible in main.cpp or in kaboutdata.cpp by using the static method instance of qcore application. And then it sets some values for the app local variable, so for the app object. If app exists, and it exists, then it says set application version F11 within kaboutdata. So since classes in Qt and C and KDE don't actually have member variables, they always have a D pointer or a pimple, then all of these accessor methods actually get at the D pointer and then get at the data inside them and present that data. So F11, this is the unique pointer C++ include. Okay, qbyte array. So this data thing is actually a method of qbyte array, which returns a char pointer C style string, 0 terminated UTF-8. And then from that UTF thing calls qstrings from UTF-8 and instantiates a qstring object. And that thing is then returned by this version method. Okay, so this returns a qstring, which is then set. This is a non-static method. This is the qstring destructor. Okay, again, D pointer and the data members are inside of this D pointer. Okay, so let's look at what D pointers are. So Qt pimple. So what's a pimple is a pointer to implementation, an implementation detail. So the implementation of public classes is split from the member variables by using another class, which is the pimple pointer to implementation. Okay. So there's two classes, coordinate dialog private and coordinate dialog. And coordinate dialog doesn't really have any data members. All of the various member variables are in fact in this instance in an instance of this class. And you can access this via a pointer which is a member of the coordinate dialog class, and it's either named d_ptr or more often d, just d. Okay. So it says d pointer. Let's look. So it says if you're inside qlabel.cpp, which is a CPP file from the Qt framework, you're going to see two classes in there. So there's qlabel private, and then there's the qlabel class. Okay, qlabel destructor, and then so the methods from qlabel private and the methods, the implementation of the methods from QLabel are defined, are implemented. So the methods of QLabel private and QLabel classes are implemented into the same file in qlabel.cpp. Okay, and the number and types of the member variables of QLabel private is a implementation detail, and it's private. You should not think about it. Binary compatibility, ABI compatibility, application binary interface compatibility. Okay. And the exported C++ classes always have the same size, which is the size of a pointer, which is, I don't know, 4 or something. If you go size of QLabel or in our example, size of kabout data, it's going to say that it has just one data member, which is this D thing. Okay. I don't know how to collapse the method docstrings yet. At the very end of the class definition, there's the only member field, which is a unique PTR, something, so a void pointer to a D, named D, to a kabout data private. So if you go size of kabout data, it will say that it just contains a void pointer, so it just contains a pointer. That's the size of the kabout data class, no matter how many member variables you actually have in kabout private, the size of kabout data is going to stay the same. So that's what it says in here. It says never change the size of an exported C++ class. And in order to get access faster from kabout data to D and from kabout data private to its twin class, to kabout data, there's C-style macros that give you easy access to from kabout data private to kabout data and from kabout data to kabout data private. Okay, so the private class or the private static class is a class or a struct. So in this example, it's actually a struct. Where are you? In here. So the private is actually a struct, and then the twin class, which is the widget, only has a member variable which points to this an instance of this struct. Okay, so just contains the private or the private static class just contains data members, nothing else. And all of the methods are defined on the twin of kabout data private, which is the class kabout data. Okay, so kabout data has member variables, these blue things, has one method. Okay, whereas kabout data is full of methods. There's a second pimple in here, kabout component private, kabout license private. Oh. Yeah, there's the twins kabout license and kabout license private. Okay. Now we know what a pimple depointer is. Let's get back to where we were. We're in a kabout data.cpp, shift F11 to get back to main.cpp. Let's close this left-hand side tab, bar, the sidebar. Okay, it exposes things over dbus, which is a method for two applications to talk to each other. So IPC inter-process communication. This is exposing C++ instances, so C++ objects in C++ types classes to the QML programming language. So there's singletons, which can be accessed from QML. There's types that can be accessed from QML. There's meta types that can be accessed from QML. Okay, and then at long last we start interpreting the QML files because there's no graphical user interface defined in tokodon outside of QML files. So all of the graphical user interface, how many windows, how many buttons, how many combo boxes, etc. is defined in .qml files, in files with the extension QML. So for that, since we run CPP in C++, we will need an instance of this class, QML application engine. So we create a local variable located on the stack. And then we say that it should use internationalization. Then we say connect, which is a Qt signal slot association. What's Qt signal slot? You should read the documentation about signals and slots from the Qt framework, and you should also watch some YouTube tutorials on signals and slots. The best YouTube tutorials that I know of are in the KDE YouTube account. So that playlist is called QML tips and tricks. So either this playlist or the playlist, where are you? Qt Widgets and more. So this playlist, Qt Widgets and more, has 99 videos. You should watch all of them. And the QML playlist has 62 YouTube videos. You should watch all of them. So the way I do it is I play this entire playlist locally in my preferred media player, video player, which is called SM Player, and I put the window with SM Player in the right hand side of the screen. So while I do things, my monitor has 1440p resolution, so 1440, so plenty of space for me to work and to leave the top right hand side corner of the screen available for the media player to play videos on and on while I work. Okay, so and I leave the volume low. I don't really understand what happens in the videos because I do my work, but some things I still get, you know, while I do my job. I can still learn a small number of things, but I learn things by having the YouTube videos play all of the 62 videos. Okay. So signal and slots. In C# this would be an event, and subscribers to that event. So an event is a generator, such as when the button was clicked, and then you can subscribe to that event. Subscribing means that you have an event implementation, which is actually a method, and you say whenever the button is clicked, you should run this event implementation, which is a method. In C# there's actually a list, so you can add more than one event implementation to the event on button click. Okay, So in Qt, you need to associate the event that's going to be triggered with the event implementation. So this is the pair that actually triggers, which is called a signal, and this is the pair that actually handles, which is called the slot. Okay. So in this case, when the QML application engine will shut down, so it will emit quit, which is a Q signal. Then the method quit of the object app should be called. So quit is a slot, which means a event implementation, while this other quit is a signal, which means an event that will get triggered. They have the same name, but they do totally different things. Okay, so whenever the QML application engine shuts down, also app, the most important object that we have in this application, which is the application itself, will need to shut down. Okay. Then we make available to the QML source code a network access manager factory. And then there's the Q command line parser, which is common to all of the KDE applications. All of the KDE applications have can be run from the command line and have the command line arguments -help, -version, -. How do I access the command line of tokodon? So I'm going to source. I'm going to run it using this code path. So source /KDE/build tokodon and then prefix, and then we go tokodon and -help. We're inside of the debugger. Let's stop the debugger. Okay, so all of the KDE applications, the executables, have -help as a command line argument, and then they have a author command line argument, which is actually populated from here, from kabout data, and then the about data we set for the app qcore application, and then for the app we also assign a command line parser, which has a description. Okay, so all of the KDE applications have -help, -author, -license, this thing which shows the GPL v3 license. -version is from the same place because the version is set in here. So it says kabout data, qstring literal tokodon version string, which is actually 22.11.2. Okay, so that's how it knows to write the name of the app and then the version of the app. Back in the debugger, we're at engine load. F5 to go to the next breakpoint, F5 to go to the next breakpoint. We don't need to step into kabout data anymore, so this is the KDE framework kcore add-ons. F5 to go to the next breakpoint. So I say that this C++ source code lines exist in all of the KDE applications, and then with the QML engine, the engine that can actually understand QML files and display them, we insert a blur hash provider inside, and then we say it should start loading QML files, starting with the entry point, which is slash, so QRC protocol, then slash, then content, then UI, then main.qml. So this file should be interpreted and displayed. So there's an application window, which is a main type of application, which will show in the iConsole taskbar in KDE, which will be managed by the server-side decoration kwin window manager. Okay, it loads. Let's put a breakpoint in here and step there. Okay, so the main application appears. The entire UI has been computed, so we know the size of the application window. But we're on the main thread. If you look at threads, there's many threads, but on the main thread, which is where's the index of the thread? So it says thread number 1 is the main thread where the UI rendering happens. If we're stopped in the debugger, or if we do a long sleep or something that doesn't allow the main thread to do its things, painting will not happen. The painting events will not happen, and you will not your main GUI application will be blocked or not render or render incorrect things. Okay. Now it sets a KDBus add-on endpoint. It does kconfig, so looks at its settings, restores the position where you put the tokodon window last time. And then the very last line that's run as part of the main function is the function that never ends, which is the main loop of the graphical user interface. So qcore application.exec, which is the main loop from the Qt framework. It's not really specific to QML, Qt Quick, or Qt Widgets. Okay, we don't have access to the source code from the CPP file for qcore application.cpp, which contains the implementation of the exec method. So we don't really know what it does. It's a static method on the class, on which class? qcore application. Okay, so similar to other UI frameworks such as Win32, System Windows Forms, etc. Painting happens on the first thread, and you need to make sure that you do all of your computations that might take too much time on other threads than the first main UI thread. So do all of the computations, network access, etc. on secondary worker threads. Okay. So we're actually running tokodon in the debugger right now, but we're not paused anywhere. So we can pause if we want. stdout and other errors are written in here in the Qt Creator ID application output alt3. So it says that mobile forms is not installed, whatever that means. Okay, we should fix all of the binding loops. Okay, so by running tokodon in the Qt Creator IDE inside of the debugger, you can actually see what is the source code of tokodon. You can look at the source code, see what other libraries are used, how it opens the QML files, what's the QML file entry point. So a ton of things, a ton of questions you can answer for yourself. So you can help yourself to learn the source code by just running inside of the debugger, the application. Okay, so this is how you understand the source code of tokodon. And again, for this KDE season of KDE 2023 idea, you're just expected to add things in the .qml files to make more buttons and other GUI elements accessible. Okay, so back to where we were. Once you edit the source code for tokodon, for instance in here, you can search the source code of tokodon. The way I do it is by using Visual Studio Code. There's the search button and left hand side toolbar, and in here I can search for, I don't know, icon. Okay, with F4 I can walk through all of the results. Okay, what else? If I edit a tokodon source code file, for instance, I don't know, I don't like the zoom in text, I want to be named zoom bigger. Okay, I save the text, and now if I try to build tokodon using kdesrc-build, it will actually not compile a version that has this text. It will actually get from the KDE Git repository the correct source code from the master branch, and it will actually build that thing. Okay, so I have a YouTube video which is called Advanced kdesrc-build. You should see this thing and see the various possibilities of command line parameters for kdesrc-build. Some are available here. Some others are available here. Okay. And in order to build as fast as possible, we go to not include dependencies. Middle click paste. And the name of the module to build, which is tokodon. Okay, it said you had local changes to tokodon which have been reapplied. So you're not sure if kdesrc-build has built the master branch from the remote origin or it has built your actual local changes. In order for kdesrc-build not to change your source code, you're going to go --no src, then --no include dependencies to only build tokodon, and then you also really want to see the results of your work, so you're going to need refresh build such that make install is run, and in ~kd/usr/bin tokodon is the freshest version of tokodon, the executable. And I sometimes also use debug to have the much more standard output from kdesrc-build, so not just 10 lines but 1000 lines. Where are you? kdesrc-build, tokodon, no include dependencies, no src refresh build. And then debug. Okay, so it did configure cmake, then it did make, which actually compiles. Okay, successfully, 100%. And then the very last thing it does, make install, which puts into tilde/kd/usr/bin the big executable tokodon. And now we can actually run that executable. We can use a different console tab for that. So we need to again source tilde/kd build tokodon and then prefix and then run tokodon. Okay, and now that zoom in feature is zoom bigger, but we cannot access that feature because we will need an actual Mastodon account, and creating a Mastodon account is not that easy because you cannot use the biggest Mastodon instance, which is so this is Mastodon, a social network similar to Twitter. People nowadays migrate from Twitter to Mastodon, and it's made up of many Mastodon servers which are federated. Some Mastodon servers can communicate to others. Some Mastodon instances refuse to federate with other Mastodon instances because there's bad content on some Mastodon instances. And the name is Eugene Rochko, Russian, German. Okay, one of the official websites is joinmastodon.org, which if you say create account, it gives you a list of 200 Mastodon servers. Many of these Mastodon servers are a joke, are hosted at home, can disappear anytime. So it's not really clear to me how you can find a Mastodon server that will survive the next 5 years and that is fast. And okay, so a Mastodon server is similar to a email server such as gmail.com in the sense that your Mastodon account actually your Mastodon account ID actually contains the instance where you created. So if your ID is John W at computerfairy.es, then you will have the handle John something at computerfairy.es. But again, you want to create a Mastodon account on a Mastodon instance that's good, that's supported, that will not go disappear in the next 2 years, or one which works 24/7, just not one which works only Mondays when the administrator remembers to actually start the virtual machine that hosts Mastodon. Okay, so what I used is I looked at the promo team from KDE. It has Mastodon accounts, and these accounts are from Mastodon from floss.social. So I tried to create an account at floss.social, and I could, but when you create a Mastodon account, the owner of the instance is actually vetting you to make sure that you're a bad actor or a good actor. In this case, you need to be a free and open source contributor in order to be accepted, in order for Floss.social to accept your request for an account on their Mastodon server. Okay. So Floss.social also has 9 to 5 Linux, OMG Ubuntu, GNOME, KDE. Oh, pretty good company. The default instance is mastodon.social, which has 200k users and is managed by this Eugene guy, which is the name that we looked at when we saw the Mastodon wiki page. So this guy, Eugene Rochko. Eugen or something. Evgen. Okay, but I could not create an account on mastodon.social because you cannot create accounts anymore. It says creating an account on mastodon.social is currently not possible. And it offers me to create an account on another Mastodon server by going back to joinmastodon.org. Okay, once you're logged in to Mastodon from Tokodon, you will be able to see timelines, notifications, post notifications, etc. And then you will have access to that menu for zooming in, where we actually edit it. Global timeline. Do we have such a string? It's actually translated. So these are the translations, the files that end with .po for different languages. And the only place that's not inside of a .po file is where this string is actually used in the UI. So it's not from QML, it's from a view model which is exposed from C++. So abstract account, abstract timeline model, etc. are other models, so C++ classes that just have data, or some abstractions that are required by QML, such as list items. Q abstract list model. Okay. Properties are exposed towards the QML source code using QProperty. So the standard Qt properties. Okay. And you can also inspect the application using this thing. Where are you? Gamma ray, KDAP gamma ray. So this is an application that allows you to see how many objects exist inside of the Tokodon GUI, how many windows, how many buttons. It allows you to edit text. It allows you to add more properties to the objects which are visible in here. The objects are evaluated at runtime. There's Qt metadata. There's properties. You can trigger events, notifications. You can see what events are triggered, etc. So gamma ray is a thing. I usually build gamma ray from source using kdesrc-build, but since this time I did not build Qt using kdesrc-build, so I'm taking Qt from the my distribution packages. Then the gamma ray package from Ubuntu should be enough for me. So let's see how that works. I started tokodon from the command line, did not put an end ampersand, so I need to pause the thing, Ctrl Z, and then BG to background it. Okay, Ctrl Shift T, let's become super user, asks for my password, and I want to search for gamma ray. Where are you? Okay, and it says that the application name is gamma ray. Apt install gamma ray. So there's plugins for Quick, for Bluetooth, for Wayland. Let's see what it actually does. It does not install the inspector for Qt Quick, which I want. Okay, so like this. Okay, this is what I want. Home. -S means that apt should not install anything, should just display what it needs to, it wants to install, so it's a dry run simulate command line parameter. I go yes, which is the default option, so I pressed enter. Okay, let's start gamma ray. Okay, I want to inspect this tokodon. So I want attach and then tokodon. Sounds okay. So these are all of the objects. Widgets. There's Qt widgets even in QML applications. In Qt Quick applications, there's a Qt desktop widget, which is this thing, part of Kwin. And then there's a Qt desktop screen widget. Or not. I know. Then there's Qt Quick, which is quick scenes, this thing. Okay, so this is an overlay, mouse area everywhere, a control in the bottom side, I don't know what that thing is, a pop-up item. I don't see that. A root item, mouse areas. Okay, so we have application window, Qt Quick content item, so the right hand side of the application. There's a page stack. There's a global toolbar UI, which has a header, which has a header item, which has a main item, which has a breadcrumb loader, which has an anchor, so where is the button? This button. So this is a breadcrumb, and this is a left handle anchor. Does it have text? Close drawer. Where is that thing? Properties. Value, sort by value. Can I pick things? I don't know. So there's a way to pick this button, which says open drawer, and then there's a way to inspect this button. So it has an icon, it doesn't have a text, it has a pop-up tooltip which says open drawer. Then you can see if it's accessible or not. You can see it's so the forward button is not enabled, not visible. Okay, it says in which file it's defined. It shows the QML source code, handle open close, global drawer. Handle open icon source. Yeah, that thing. So it's open drawer right now, and goes sidebar collapse left. Doesn't do such. Search, Control V, click on this thing. Appears just in one place. Handle open icon. I don't know. So you can totally inspect anything using gamma ray. Gamma ray, the application, so is very powerful, allows you to inspect anything. It allows you to edit a lot of things. So you can edit texts and properties and a lot of things. But sometimes crashes. Not a problem, you just start gamma ray again. You just pretend it never crashed. Shader fragments. Okay, the real way to see what's inside of a QML application is to open it in gamma ray and see all of the million fragment shaders and QSB files and PNGs and all of the things that are available and how they are distributed in the QRC protocol to look at all of the signals. So when a signal is triggered, where are you? You will be able to see it in here. But you will also be able to crash gamma ray really easily by going to these tabs in gamma ray that show too much information, way too much information. Styles, I don't know what this thing is. Themes, so this is the KDE theme. Color palette. Network access. There's a search model that you can inspect. So the Kirigami objects. Okay, about data, this guy. How do we inspect this thing? The richness is infinite of the things that can be read at runtime and written at runtime. Timers, translations, a ton of things in here. Okay, really important to make sure that you build KDE applications using the CMake build configuration debug, not relu with the info. Okay, so if the orca cannot read an application, you would need to export these things. So in the tab where you start tokodon, you would have to paste this block of environment variables. I'm using bash, and then you start the application that is going to be read by orca. If orca cannot read it directly, that means that these environment variables are not enabled before you start the tokodon, so tokodon will not export the inter-process communication necessary for the at-spi accessibility toolkit to be able to talk to the tokodon application. Okay, so we've used exerciser, we've used orca, a member of this block, so freedesktop.org/wiki accessibility at-spi.2. Okay, and it says that if you want to play around with the values that are exposed via accessibility and to actually click on buttons using accessibility, your best bet are using the Python bindings by at-spi2, this thing. This is installed by default on my machine. So the way to play with it, where is it? An example of playing with it, like this. You go in a file with extension PI, so a Python file, import py at-spi, then you get the entire desktop, then you look for all of the applications inside of the desktop, you print all of their names, then you look inside of one application. It will say all of the things that are accessible that are inside of the application. So it will say it's just a frame named character map. And then you can print the role and the name. So this is the name, this is the role. Okay. Then you can go deeper and deeper. The controls that are accessible are in the form of a tree. The top of the tree is called desktop. Under that there's applications. And then under the application, then there's a frame or something, so a container. Inside you can have a main menu, a status bar, text, etc., etc. So everything is represented as a tree that you can then navigate. There's query text. you can get this place on the screen where the accessible control is displayed. You can watch for events happening and being triggered. Okay, so that was all I know about the first part, where you edit QML files in many of the KDE QML applications such that more and more of the graphical user interface is readable using orca, the screen reader. And in part 2 it says that using the accessibility framework, so read the tree of accessible GUI controls, read their properties, and then you can actually press buttons and do actions with those accessible objects. So for that, that thing can be used to create GUI tests, graphical user interface tests, that are more stable in time and less flaky than tests of type click at coordinate X and Y. Okay, and it says that, for instance, for tokodon, we should create such a test where we disable the network connection, and we mock, or we create test doubles for all of the network traffic. And then using the accessibility framework, we read the tree of accessible controls and we click on them. And such an example is this one, using Selenium, which is a web UI front-end driver, which contains the engine of Chromium and Google Chrome V8 JavaScript engine. And the KDE developers have started and created this KDE Git repository, which uses Selenium and at-spi, which is the accessibility framework used by KDE applications. And there's an example for the application kcalc. The application kcalc being the KDE desktop calculator application, so this thing. So it starts it, and then where does it start it? In here. So it says desired caps or.kd.calc.desktop. Then it says for each of the test methods, such as test initialize, test addition, test combination, etc. So for instance, for the test initialize, the first thing that gets run is setup, which finds an element with the name AC, this thing, and then using accessibility finds the element, so this button, and then using accessibility it clicks on this button, so it clicks on AC. Okay, and then it waits until this control says the string 0. So wait until self get results equals 0, and then it runs the first test, which is test initialize, says find the button with the name AC and click on it, find the button with the name 7 and click on it, and then look at the results. So this 7 should match this 7, so assert that 7 is actually 7. And then it goes to the next test addition. Before running the test, it actually runs the setup. So find the button AC and click on it, this thing. Wait until the result becomes 0, it's 0. Then it runs test addition, finds the button with the name 1 and clicks on it. Finds the button with the name plus and clicks on it. Finds the button with the name 7 and clicks on it. Finds the button with the name equals and clicks on it. And then make sure that the results is actually 8, which it is. Then again setup, press on AC, then the next text, which is test combination. So press on 7, press on times, press on 9, press on plus, press on 1, press on equals, press on division, press on 8, press on equals, and it should be 8. Okay. So a season of KDE idea would be to add such tests to QML applications such as tokodon. You could start with easier applications such as kalk, the Kirigami QML KDE application. That's a sibling to the kcalc application. So this application is written in KDE in Qt Widgets, and kalk is written in QML. So let's see how kalk looks like. kdesrc-build kalk. Okay, so it builds Kirigami, depends on Kirigami. And then at the end, it builds the the correct Git repository, which is kalk. Okay, kdesrc-run kalk. This thing. So it crashes because Qt feedback is not installed. What's that thing? Let's search Qt feedback. Feedback. The list is too long. Grep Qt. Okay, so says that libqt feedback is not installed, and we probably need the dev package for it. Not installed. Control middle click paste and enter. So it installs two things, the .so files and the /usr/include files. Okay, let's open kcalc again. Calc again. Okay, and now it complains that Qt feedback is not installed. How could it not be? We just install it. QML module Qt feedback. This is what it probably requires. Okay. Okay, so similar applications, but different toolkits. So this uses Qt framework, Qt Widgets, and this uses Qt framework, Qt Quick QML, Qt Quick Controls 2, Kirigami. Binary calculator. This thing. No. With the left bitwise shift operators. There's, I don't know. Okay, and k about data, k about box is this thing in Qt Widgets, and is this thing in QML. The same information but displayed differently. So in here it occupies the entire application. In here is a separate window. About, so KDE calculator, who, KDE community, libraries in use is in here a tab, and in here is a list. Authors, donate, report a bug, license, so license is this part, GPL v2, get involved, where is get involved? In the other dialog, this thing, join and contribute. Okay, it selected the correct product, KTalk. The wrong page. Because this application is older installed from Ubuntu, and this is the latest and greatest from KDE Kitmaster you built using kdesrc-build. Okay, so I would suggest you build for the part 2, you build kalk using kdesrc-build, and then you write a similar test to what Harald did. So Harald did it for kcalc, so you will do it for kalk, the other application, the Kirigami application. Okay. If you want to work on individual apps such as tokodon, there's matrix channels for each and every, for most of the applications. For accessibility, there's a matrix channel. For new contributors to KDE, there's a matrix channel. And once you're no longer a new contributor, you could use the KDE devel matrix channel for the developers. Okay, so that's all that I know about this SOK idea, about part 1 and about part 2. Okay, so you will need to read this blog post and understand what's happening in here. Okay, so from my YouTube channel, for this we used KDAP gamma ray to know how to use gamma ray to inspect. Probably Qt creator and kdesrc-build. We downloaded and installed Qt creator from the Qt website, so this YouTube video. Advanced kdesrc-build tutorial for the long command line. When you go kdesrc-build, then tokodon, then --debug, --no, -src, -no, -include, -dependencies, and then --refresh, -build. For another QML application, you could watch the kcalc tutorial. For how to run exerciser using this ID for Perl and Python. This would be the video learn Perl exemplified using kdesrc-build. For how to do a git merge request, a git commit, we have this tutorial, git tutorial. General matters, how to start programming for KDE. Start programming for KDE tutorial for beginners. For kcalc, we also have one. Okay, so this is it. Thank you.